All right, people, you ready? Newton's second law, how do we use F equals ma? This will be on your test. You won't have to memorize the equation because it's so long. Look how complex it is. But you also have to be able to use this equation to solve for mass and for acceleration as well. So let me show you the same equation that is rearranged to solve for mass or for acceleration. Okay? Remember that when you have an object or something like mass that is tied up in acceleration with multiplication right there, you use division to undo that. So if we want to get mass by itself or acceleration by itself, we just use division to move the other object or the other variable, to the other side of the equation. So if we solve for force, this is our equation, right? If we want to solve for mass, if we want to know what mass is, well, then we have to use division to get acceleration out of there. We divide both sides of the equation by acceleration because we have an equal sign here. We have to keep it equal. This cancels, and so we have mass is equal to this right here, force divided by acceleration. Okay? So if you're doing a word problem and they're asking for mass, what's the mass of, then you'll use this version of the equation. All right? If we reset this, and we take the original equation of F equals ma, but now we want to solve for acceleration. Let's say a problem is asking us to describe the acceleration of an object, and we have to use force and mass. We'll use division again, and we'll get mass to the other side of the equation. We can undo that multiplication, by division. The equal sign says we have to do both sides of the equation to keep them equal. And we get to cancel m over m because that's just a fancy way of writing the word 1. Mathematically, that's not going to change our answer at all, so we can cancel that right there. And so acceleration is this equation right here, this relationship, force divided by mass. And so we could potentially solve for force, we could solve for mass, or we could solve for acceleration. It's all the same relationship, and it's called Newton's second law, right? So a quick example would be if we were trying to figure out how much force had to be applied to an object to make the acceleration, let's just say 10 meters per second, right? So if we already know that acceleration is 10 meters per second squared, sorry, I should have said meters per second squared earlier, and we're pushing an object, right? What is it? So let's say it's a 500 kilogram object, which is pretty heavy. There's our mass, 500 kilograms. Well, what force do you have to apply to an object that's 500 kilograms to get it to accelerate 10 meters per second squared? Well, it's F equals ma is our relationship, right? So the force you have to apply is equal to the mass multiplied by the acceleration. We already know the mass. It's right here, so we'll plug that in. And we already know the acceleration. That's it right there, okay? So at this point, it becomes plug and chug. The force is going to be equal to the 500 kilogram object multiplied by the acceleration, how fast you want it to change its speed. And those two things multiplied together are going to give you 5,000, right? But remember, in this class, when the problem like this, you can't just write a number. That's going to get you half your points. To get the other half of your points, you have to describe 5,000 what, right? If you're at a total loss, then just do the same math with your units in the equation and see what you come up with. So we took kilograms and we multiplied them by meters per second squared. And that would actually be totally acceptable. Okay, a kilogram times meters per second squared is actually equal to a Newton. And so you could also write it as 5,000 newtons with a capital N, and you would be just fine. Okay? Remember, if you do one of these problems and you end up solving for acceleration, well, then your units should be in meters per second squared. And if you end up solving for mass, then your unit should be in kilograms. All right? If you need more prep, more practice, come and see me.